Hi, everyone. Welcome to UBC's Materials Engineering. We're very excited to meet you. Materials engineering is where we explore materials from its inception to its processing and then later to its optimization. So let's get into what this means. So firstly, what exactly is materials engineering? Well, materials engineers study how materials are made, how they're used in different applications, and how the materials can be reused after they've been exhausted. This can happen on any scale from tiny nanotubes to giant airplanes. Materials engineers study all of these scales of materials and attempt to predict material behavior in a vast number of situations. So here you will see a layer of metal being 3D printed. This machine uses an electron beam to melt a layer of metallic powder that then bonds to the layer below. When this piece is completed, a materials engineer would ask, did the material in this process behave in its expected way? Did the material fail? And if so, how did it fail? So at UBC, what can you expect to do in your materials engineering degree? Well, our department is especially successful in providing an engaging environment to first learn and strengthen the fundamentals of materials engineering, and then to use those fundamentals to derive solutions to complex world issues. Because of our small class size, we're able to provide a lot of hands-on learning via lab courses and lectures. A few of our professors have even adopted the reverse classroom learning technique, where students listen to lectures at home, but use class time for deeper discussions, projects, and questions. To complement your lectures, you can expect to apply your learning by testing materials' properties and characteristics with our ever-increasing repertoire of equipment. You will be learning about what software is in use in the industry and how we can use these tools to predict material behavior. You will learn to analyze how and why materials fail by actually breaking some materials. So past the fundamentals in fourth year, you can select a specific stream within the materials engineering department. We currently offer 3 options: materials manufacturing and performance, which often looks at the big picture side of things. This can entail analysis of the material structure and its effects on properties and how this can scale up to large structural components. The biomaterials option is focused on creating solutions for the human body. It studies how materials behave inside our bodies, how we can make them more biocompatible, or how we can actually innovate more biocompatible materials. And lastly, the minerals and the metals extraction option is dedicated to studying how we can get valuable materials from the ores that get mined. This includes understanding the material chemistry and how it is impacted by extraction techniques. So what is the industry demand for materials engineering? So what does the real world look like and ask for? Well, materials engineers work in a vast array of industries. So this can include innovation, renewables, corrosion, aerospace, marine, and most recently, battery manufacturing. Materials engineers are also in demand with about 4,000 jobs across Canada right now. But specifically, what career options can you pursue with your materials engineering degree? Well, our students have gone on to some very exciting opportunities. We've created process engineers across many industries, from extraction to brewing. Some of our alumni have worked for innovative startups, providing materials expertise in a variety of applications. You could be a quality engineer, ensuring that products and their materials match specifications. And lastly, if you've ever related to Horatio on CSI Miami, you can become a forensic engineer and investigate how and why materials fail. So what can you expect from your student experience? Well, to truly understand engineering, one has to do engineering. The materials engineering program offers 3 distinct opportunities to do engineering. The first of these is the co-op program. This is a 1-year work placement program that is spread out throughout the materials engineering degree after second year. Students apply to it in the fall of second year. They take workshops in resume building, cover letter writing, and interviewing skills. At the end of the second year, they actually start their first co-op work placement. The second of these is the Undergraduate Student Research Awards. If you feel passionately about research, or if you even just want to know what that entails, you can connect with a professor in the department to apply for these funds. This is a really good way to understand the everyday ins and outs of research and to potentially get a feel for what grad school could be like. So we realize engineering happens differently in different places. The coordinated international experience allows students to go on exchange and take engineering courses at our partner universities. So CIE gives opportunities to learn engineering in a different way in a different country, but still be able to come back and have those courses translate to UBC's materials engineering program. Well, okay, so we know it's important to have a strong foundation, but we also know that good engineers are well-rounded. We really encourage our students to get involved in as many ways as they can on campus. One way to get a more expansive engineering experience is to join a student design team. These engineering teams are led by students in every manner. For example, Vulcan, the materials student design team, is focused on forging a blade from start to finish. Design teams help our students understand in greater depth what they have already learned in class by being able to actually implement it. Our students have also had a strong affinity to leadership. One of the recent engineering undergraduate society presidents was a materials engineer. A few of our students have served on the UBC Student Senate to be able to impact greater change across campus. So materials engineers do a vast majority of things, all focused on how materials behave in various conditions and how that can affect our physical world. We really thank you for joining us today, and we'd be happy to take any questions now.